Good morning, students. Today we are going to video number 10, example 5. I read. 3 forces, 2 Newton, 60 degrees. You see, these 3 forces are given in polar coordinate form. Polar coordinate form in the sense that the magnitude of the force is given, the direction is given in coordinates, the magnitude of the force and the direction of that force. They are given in polar coordinate form. This is what we call polar coordinate form. So, 3 forces, 2 Newton, 60 degree, comma, 4.5 Newton, 180 degree, and 5 Newton, 300 degree, act on a body of mass 2 kg, which is initially at rest. Find 1. The resultant force on the body. 2. The acceleration with which the body begins to move. So the first thing we do now is to draw the force diagram using the information provided. We draw the force diagram. We start by first of all drawing the coordinate system, that is x and y axis. X and y axis. This is x. This is the origin. That is y. Now we locate the first force. The first force is 2 Newton. Direction 60 degree. So now when the direction is given in this way, it means it is 60 degree measured from the north. So this kind of directions are measured from the north. From the north here. So you can measure 60 degree. You don't need protractor, you just estimate. From the north, you measure an angle of 60 degree. 60 degree. So that is 60 degree. So that is that first force of magnitude 2 Newton. If from the north here, the line of action of the force is 60 degree, then the remaining angle to the horizontal, 60 from 90, that will be 30 degree. So that is, we have located that first force. Then we move to the second force, 4.5 Newton, 180 degree. Again, this 180 Newton is measured from the north, clockwise. Measured from the north, clockwise. So if we measure from the north, that angle of 180 degree will be here. That will be the negative direction of the y-axis. So meaning that the line of action of that second force will be 4.5 Newton. That is the second force. Then the third force. The third force is 5 Newton, 300 degree. Now, again, always, all angles are measured from the north clockwise. If we measure like this, from here to here is 180. From here to here is 270. Then take 270 from 300. That will be 30 degree. Then the remaining 30 degree will be in this second quadrant. So we draw, that is the direction of the second, of the third force. That's the direction of the third force. So this is 30 degree. Because 30 degree plus 270 will give you 300, which is this. So this is how we have this is the force diagram, the required force diagram. So the question now is, we should find the resultant force of the body. To find the resultant force, we find the horizontal and vertical components. We find the horizontal and vertical components. This is horizontal. Horizontal component. Horizontal component. F sub x. Then this will be the vertical component. F sub y. In the tabular form, like that. The tabular form. You can clean this side.
Yeah, you can clean it.
So this is the force. Force. That is force. The first force is 2 Newton. 2 Newton force. So 2 Newton force. The 2 Newton force. The 2 Newton force is, if you can see, so this is the 2 Newton force is a static degree to the horizontal. Then the horizontal component of that 2 Newton force will be horizontal component will be 2 cos 30 degree. The vertical component will be 2 sine 30 degree. So this 2 sine 30 degree is 2 times 0.5, which is 1.0 Newton. 1.0 Newton. Then, have I written? Yes, it's okay. Then here, 2 times 0.866. That's my calculator. I forgot to get. 2 times
1.732.
1.732. So that is that. Then the second force. The second force is 4.5 Newton. At an angle of to the horizontal. Now, at an angle of 90 degrees to the horizontal, you know? Yes?
It is.
That would be 4.5 cos 90 degree. Cos 90 degree, is it not 0?
Yeah, it is.
So that is 4.5 times 0, which is 0 Newton. Then the vertical component is 4.5. The vertical component will be 4.5 sine 90 degree. 4.5 sine.
Minus now.
Yes. Minus, because it's towards the negative direction of the y-axis, so it will be minus. Minus 4.5 sine 90 degrees. Sine 90 is 1. So that would be minus 4.5 times 1, which is minus 4.5. 4.5. So I continue from here. This is horizontal horizontal component, vertical component. So, continuation, that is the third force now is, the third force is 5 Newton. 5 Newton. Capture this again. 5 Newton. So that will be, the horizontal component will be, anyway, the force is, force force 5 Newton force. So this will be minus 5 cos 30 degree. Cos 30 degree, yes. And that will be minus 5 times 0.866.
4.3301. It's 5 cos 30.
This is minus 5 times, please don't capture this yet.
Okay.
Minus 5 times 0.866. So you have
4.3301. 01.
01.
Yes.
I think I leave it 2 decimal places.
Okay.
So here, this would be minus, plus 5 sine 30 degree, the vertical component.
Yes.
So that would be 5 times 0.5, which is 2.5 Newton. Then, summation now. Summation f sub x. Summation f sub x is equals to, starting from here, starting from
732
1.732 plus 0 plus
minus
minus 4.32. So
the answer is minus 2.598.
598
Yes.
Newton. Then for the vertical component, summation f sub y is equals to, for the vertical component, this is 1.0 plus minus 4.5
Plus 2.5.
plus 2.5.
Minus 1.
So that is equals to minus 1.0 Newton. I hope you understand this method.
Yes.
So now, we've known the sum of the, I can now clean the question. Clean the question. Summation f of x is equals to minus 2.5 Newton. Summation f sub y is equals to, oh, they are both minus.
Yes.
They are all minus.
Both are negative.
Minus 1.0 Newton. So, now, the question says, find the magnitude and direction of the resultant force. Now, how do you find the resultant force? Therefore, the resultant force is the root of summation f sub x square plus summation f sub y square.
That's from 1 figure 1.
So that is equals to of summation f sub x is minus 2.5 squared plus summation f sub y minus 1.0 squared.
Now, isn't it 2 point? Okay, 2 point minus 2.598. Is that not what we got?
Minus 2 point what?
598.
Oh, okay, it's true, yes. .598 what?
Yes.
All squared plus minus 1.0 all squared.
So that would be 6.7.
This minus 2.598. Huh?
Yes, 6.749.
Plus
9.
1.
Okay, approximately 6.745. 6.750 approximately.
Okay, but we can leave it like this, huh?
No, there is 6 after 9.
Okay, there is 6 here.
Yes.
Okay, then we can make it
50.
6.50. So that would be the root of 7.750.
Equal to 2.78
78
newtons.
Now the resultant force. Then the direction.
That's Roman figure 1. The question did not say we should find direction, only the resultant force on the body.
Okay.
The resultant force on the body, that's all.
But we have to present the answer in the way other forces are presented. So we want to find the direction. Can I clear this side?
Yes.
We need to find the direction. To find the direction, we now draw the vector diagram of these two forces. Summation f sub x, summation f sub y. Now, summation f sub x is minus 2.5 now. So we draw that summation f sub x horizontally towards left because it's negative. Towards left. So this is summation f sub x. Summation f sub x. Which is minus 2.5 dt. No, 2.598.
98.
2.598 Newton. Then summation f of y is also negative, minus 1 Newton. Then from the head of summation f of x, we draw a vertical line, vertically downward because it is negative. Downward in the negative direction of the y-axis because it is negative. So from the head of that summation f of x, I draw that vertical line downwards. So that is summation f of y equals to minus 1 Newton. Then the next thing now is to close the polygon. I now close the polygon. Close the polygon. So now this third line is the line of action of resultant force. But in which direction will be the arrow? So we have to look at here. It's coming this way, it's coming this way. So the resultant force, the direction of the resultant force should oppose the other two forces. So it should be in this direction. In this direction. That is the resultant force. and this is at right angle. Then, so, how do you calculate the direction of the resultant force? To calculate the direction of the resultant force, here we have to draw right from the originating point of the resultant force. We draw our knot south. This is north. So this is the north. Then the direction of the resultant force will be from here to here. That's the direction of the resultant force. That angle. So how do we get it? We first of all calculate this angle theta, that very angle. We can get it, then we take it from, so that here tan theta, this is right angle triangle. The tangent of this theta is opposite over adjacent. That is summation f of y over summation f of x. And that is going to be minus 2 point.
Minus 1.
Minus 1.0 Newton over minus 2.598 Newton. Newton will cancel out. Minus will cancel minus.
0.3849.
Okay. Therefore, tan theta is equals to 0. What?
3849. 49. Yes, 9.
49.
Yes.
So theta is equals to the tan inverse of 0.3849. Theta is equals to
21.05.
21.05
degree.
Therefore, direction now. Direction of the resultant force. Force R is equals to the whole of this 270 degree minus 21.05 degree.
248.95.
248.95
degree.
248.95
degree.
degree. So that will be approximately equals to 249. 249 degree. So this side connecting. Connecting the other side.
Yes.
How is equals to, that was my resultant, 2.78 Newton, 2.78 Newton, 249 degree. That is my answer.
Second part.
Second part, acceleration, right?
With which the body begins to move.
Acceleration A. Acceleration A equals what? So now we do know that the resultant force, i.e. from Newton's second law of motion, F equals ma, i.e. F in this case is the resultant force. The resultant force F is equals to ma. And what is this resultant force F? So I have 2.78 is equals to ma, but the mass
2 kg. We are given 2 kg.
So 2a. Therefore, 2a equals 2.78. Therefore, a equals 2.78 over 2.
1.39.
1.39 meter per second square. I don't know this.